Hi, it's Jo Karen Hudson speaking. Today we're going to talk about functional notation. So let's start off with some definitions. First of all, a relation is a set of ordered pairs. And you remember about ordered pairs. It's a set of ordered pairs. That's just one ordered pair. A function is a special type of relation in which no x values are repeated. It's a very easy definition for a function. No x values repeated. The domain is the set of all x values. The range is the set of all y values. Determine if the relation is a function and give the domain and range. So we have a set of ordered pairs here. Let's see, the x values are -3, 0, 1, 3, and 5. Did we repeat any of the x values? -3, 0, 1, 3, and 5. We did not repeat any x values, so yes, it is a function because no x values are repeated. The domain, -3, 0, just writing down the x values, 3, and 5. The range is the set of all the y values. The set of all the y values. Let's see, the range would be -2, 7, 9, -1. -1 is used twice, but we don't put it twice in our set notation. Okay, example 2. We want to determine if this is a function. Let's look at the x values. 1, 2, 3, 4, 5. They're all different. Yes, it's a function. None of them are repeated. Let's look at the y values. Okay, let's get the domain. The domain is the set of all x values, 1, 2, 3, 4, 5, and it looks like every y value is the same. You don't repeat it in your set, just put it one time. Now this one looks a little different, but we can write it in set notation if we care to. Let's see, -1 pairs up with 5, and 2 pairs up with -2, and 5 pairs up with -2, and 11 pairs up with 5, and 11 also pairs up with 11. There's 2 arrows coming out of this, and that's your signal that that's not going to be a function because we are repeating x values. 11 is repeated. This is not a function. We have repeated 2 x values. The domain is the x values, -1, 2, 5, and 11. We don't want to write the 11 twice. And the y values are 5, -2, and we don't repeat this -2, and we don't repeat the 5, and 11. So there's only 3 different ones there. The vertical line test in evaluating functions, starting with the definition. The graph of a function can be intersected at most one time by a vertical line. This is called the vertical line test for functions. It's very easy to work with. We use the vertical line test to determine whether the graph is a function and then state the domain and range. So what we're doing is we're drawing a vertical line. And I'm going to do it with a little ruler, try to get it straight. How many times did I hit the graph? Once. Let's draw another vertical line. It has to be a vertical line. It's called the vertical line test. The line has to be vertical. How many times did I hit the graph of the line that was already on there? Once. One more. How many times did the vertical line hit the graph? One time. This passes the vertical line test. Any vertical line that I have drawn has only hit the graph one time. So yes, it is a function. Now, thinking about the domain and the range, I'm going to erase those real quick so that I can concentrate on the graph of the line. So I'm looking at this line here, and when I think of domain, I like to think of how far left and how far right. I think that's an easy way. How far left and how far right. It's from left to right. How far left does this graph go? Well, it continues as you move the graph along straight. It continues to go further and further to the left. How far right? It continues to go further and further to the right. How far to the left? All the way to negative infinity. How far to the right? All the way to positive infinity. The range is how low and how high. You're talking about the y values now, how low and how high. How low does this go? How far down does this graph go? It just keeps going further and further down, all the way to negative infinity. How high does this graph get? It continues to go up, 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 all the way to positive infinity. All right, we have another graph. Let's do the vertical line test to see if it's a function. Vertical line, how many times does it hit? One time. Vertical line, how many times does it hit the graph? One time. One more vertical line. That wasn't very straight. How many times does it hit the graph? One time. Yes, it is a function. Now, I'm going to erase so we can concentrate on the actual graph. This is supposed to be a parabola. Okay. Now, we want to know how far left does the graph go. And you will see as this graph continues, it spreads further and further to the left and further to the right. How far left? Negative infinity. How far right? Positive infinity. The range is how low and how high. How low? How low does this go? It keeps on going lower and lower and lower. It goes all the way down to negative infinity. How high does it go? All the way up to here. Goes all the way up to here. And where's here on the y-axis? It's at 6. Goes from negative infinity all the way up to 6. All right, we have another graph. We want to do the vertical line test. How many times does the vertical line hit this one? Well, we only have to make one vertical line here because it hits it in 2 places, which means it is not a function. So I'm going to erase the vertical line, and then I'm going to try to make a little better parabola here. For the domain, we want to know how far left does this go. How far left does it go? It goes all the way to 2. And how far right does it go? Further and further and further to the right, all the way to infinity. Infinity always has a parenthesis around it because infinity could never be captured. Now, we're thinking on the range, how low and how high. How low does this go? Keeps getting lower and lower and lower. How high does it go? Keeps getting higher and higher and higher. Goes from negative infinity to positive infinity. In this one, we'll draw ourselves. We have the equation y equals 3x plus 5. If you remember y equals mx plus b form, b is 5, the beginning point is 5, and the slope is 3 over 1. So it begins at 5, and it goes up 1, 2, 3, and over 1. So this graph looks like this. We could have also done this by plotting points, and we would have gotten the exact same graph. If I'd have let x be 0, I'd have had 3 times 0 plus 5, which would have been 5. If I'd have let x be 1, I'd have 3 times 1 plus 5, which is 8. And it would have given me the exact same graph. Now let's give it the vertical line test. How many times does a vertical line hit this? Well, regardless of how many times I put a vertical line on this, let me make it Regardless of how many times I make a vertical line, I will only hit that line in one spot. It is a function. It is a function. It passes the vertical line test. This is Jo Karen Hudson. Thank you and have a wonderful day.